Welcome, everyone. Today, we are taking a senior-level look at Ensemble retrievers. We will focus specifically on the powerful concept of weighing multiple data sources to get the absolute best retrieval performance in your RAG applications. Let's dive in. Let's define what we mean by an Ensemble retriever. In standard RAG pipelines, developers often rely entirely on a single vector database. While vector search is incredible for understanding the semantic meaning of a query, it has a massive blind spot. It frequently fails at exact keyword matching. If a user searches for a specific product ID or acronym, the vector search might miss it completely. An Ensemble retriever solves this. It takes your user's query and fires it across multiple, distinct retrieval algorithms simultaneously, typically pairing a dense vector search with a sparse keyword search like BM25. It then acts as a master orchestrator, gathering the results from both sources and merging them into one superior, comprehensive list of documents. Look at this flowchart to visualize the architecture. On the left, our user query comes in. Instead of a single path, it splits. It hits the dense retriever, which looks for conceptual meaning, and the sparse retriever, which looks for exact keyword matches. Both data sources return their findings to the central Ensemble retriever block. This block merges the two distinct streams into the combined high-quality results box on the right. We get the best of both worlds. To understand how to weigh our sources, we must understand the fundamental difference between our search types. Semantic search, driven by dense vector embeddings, excels at understanding concepts. If you ask, why does the system crash, it finds documents about system failures, even if the word crash isn't explicitly used. However, it struggles with highly specific terminology. Lexical search, also known as sparse retrieval, uses algorithms like BM25. It doesn't understand concepts. It counts exact word frequencies. It is exceptionally good at finding a specific string, like error code 0x800400154. By combining these two distinct data sources into an ensemble, we create a true hybrid search. This hybrid approach ensures our LLM receives context that satisfies both the user's conceptual intent and their exact technical phrasing. This diagram breaks down the underlying data structures. Our document corpus at the top splits into two preparation paths. On the left, we generate mathematical embeddings and store them in a vector database to capture semantic strings. On the right, we build an inverted index mapping words to their locations and store it in a BM25 keyword index. These two separate databases form the dual foundation of our ensemble strategy. Why do we need to weigh these data sources? Because in production, not all search methods are equally valuable for your specific business domain. If we just blindly merge the results 50/50ths, we might dilute the accuracy of our system. Weighing allows us as architects to prioritize one retrieval method over another. For example, you might discover that in your application, semantic meaning should drive 70% of the ranking, while exact keyword matches should influence the remaining 30%. By adjusting these weights, you prevent a scenario where a vector search retrieves 10 conceptually similar but ultimately useless documents that bury the one document containing the exact product ID the user searched for. Weighing gives you a precise dial to tune the noise-to-signal ratio. Here we visualize the weighing mechanism. Notice the specific values on the arrows. The vector results flow into the weighting engine with a heavy multiplier of 0.7. The BM25 results flow in with a lighter multiplier of 0.3. The central weighting engine applies these multipliers to the respective scores, resulting in the optimized ranked output on the right. It is a controlled, mathematically balanced merge. How does the ensemble actually merge these lists? It uses a brilliant algorithm called reciprocal rank fusion, or RRF. The core problem is that a vector database outputs cosine distance scores, while BM25 outputs frequency scores. You cannot simply compare these raw numbers. It's like comparing apples to oranges. RRF solves this by ignoring the absolute scores entirely. Instead, it looks at the relative rank or position of the document in each respective list. It assigns a new score using a formula based on 1/rank, and then multiplies that by the custom weights we defined. The ultimate result is that if a document ranks highly in the vector search and highly in the keyword search, its RRF score compounds, pushing it to the absolute top of our final context window. It perfectly surfaces the most universally relevant data. This diagram illustrates the RRF process. We see a specific document that achieved rank 1 in the vector search, but rank 3 in the BM25 search. Both of these positional rankings feed into the central RRF algorithm block. The algorithm calculates the positional fractions, applies our custom source weights, and generates a new ensemble score, crowning it the final top document. Let's look at how to implement this in code. Writing an RF algorithm from scratch with parallel async execution is difficult. Fortunately, LangChain provides the Ensemble Retriever class. The implementation is incredibly elegant. First, you initialize your standard vector retriever, perhaps pointing to face or chroma. Next, you initialize a BM25 retriever mapped to your document corpus. Then, you simply wrap them together by instantiating the Ensemble Retriever. You pass it a list of your retrievers and, critically, a list of your weights. For instance, weights sadface 0.7, 0.3. Under the hood, when you invoke this ensemble, the framework automatically parallelizes the database calls, applies the reciprocal rank fusion math utilizing those exact weights, deduplicates the results, and hands your LLM a perfectly curated list of context documents. Here we see the class architecture. The Ensemble Retriever sits at the top as the master orchestrator. Notice its key properties, a list of retrievers and a list of weights. It points downward to the vector store retriever, applying a 0.7 weight, and points to the BM25 retriever, applying a 0.3 weight. When the invoke method is called, it abstracts all the complexity away from the developer. Let's apply this to a real-time, highly impactful use case, an enterprise IT troubleshooting agent. A frantic engineer asks the bot, "Why is my database failing with ERR 404 after the firmware update?" If we only used vector search, the system might pull generic documents about database connection drops, missing the specific error code entirely. If we only used BM25, it might pull a glossary defining ERR 404, missing the context of the firmware update. But by using a 50/50ths weighted ensemble retriever, the BM25 source locks onto ERR 404, while the vector source locks onto the semantic concept of firmware causing database failure. The RRF algorithm merges them, ensuring the LLM is fed both the exact technical manual and the conceptual troubleshooting guide. The resulting AI answer is highly specific, deeply contextual, and resolves the ticket instantly. Follow the data flow for our IT scenario. The specific query enters on the left and splits. The vector path grabs conceptual guides. The BM25 path grabs exact code manuals. The ensemble block in the center, balanced at 50/50, merges these critical pieces of data. This perfect context flows into the LLM, resulting in the green precise resolution block. It's a flawless execution of hybrid search. As we wrap up, remember that defining weights is not a set it and forget it task. It is highly domain dependent. If your application deals with dense legal contracts or complex part numbers, you should increase the BM25 weight to prioritize exact matching. Conversely, if you are building a bot to analyze customer sentiment or broad FAQs, increase the dense vector weight to favor conceptual understanding. You should continuously use tracing tools to evaluate which underlying retriever is actually supplying the winning document and adjust your weights accordingly. Mastering ensemble retrievers elevates your RAG pipelines from experimental toys to robust, enterprise-grade systems. Thank you so much for joining this training. I invite you all to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and exclusive interview guides. Keep building and see you next time. Our final diagram illustrates the continuous optimization loop. You start by analyzing your domain. You set your initial weights, choosing to favor BM25 if it's jargon-heavy or vector if it's concept-heavy. You then deploy and move to evaluate and iterate. The dotted line shows that based on your evaluation, you loop back to refine and adjust those weights over time. It is a continuous process of engineering excellence.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this and all the practice papers are available here. Today we have 5 practice papers paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.